Chapter 2, Thermochemistry. It is a study of heat energy. I'm going to make a full summary for all the enthalpies definition that you should remember. But first, look at the definition of that enthalpy itself, which has a symbol of H. It is a total value of energy of a system at constant pressure. While the definition of standard enthalpy change, we still have the word enthalpy, right? So you must write the letter H first. And then we have the standard. Okay. So when you encounter a standard word in your definition, you must put a theta symbol. And then change. So you must put the delta symbol. So standard enthalpy change has a symbol of delta H, theta. The definition is that it is the difference between enthalpy of reactant and enthalpy of product. So what does the theta symbol represent? It represents the changes that happen in standard condition. So make a note that I wrote it as conditions. So what are the conditions of standard enthalpy change? Well, that would be 298 Kelvin and the pressure of 1 atm. Or you can write the Kelvin into temperature as 25 degrees Celsius. Well, I'll accept both. The big two definitions of standard enthalpy are the standard enthalpy of formation and the standard enthalpy of combustion. So what are the differences between these two? For the standard enthalpy of formation, it means when the heat change when 1 mole of a compound is formed from its constituent elements under standard conditions. And then you must list out what are the standard conditions, which are 298 Kelvin and pressure of 1 atm. The delta H, for standard enthalpy of formation would be has a positive or negative value. So you must highlight this. The definition states that the heat change, when there is a definition of heat change, it means that the delta H can be either in positive or negative value. Okay, you must refer to your own definition. But for the standard enthalpy of combustion, it is the heat release. You must highlight this word. When 1 mole of substance is completely burnt in excess oxygen under standard conditions. Again, you must state what are the conditions, which are 298 Kelvin and 1 atm. For this kind of definition, you should be able to get 2 marks. First, when you are defining the standard enthalpy of combustion up until here, and then when you state what are the conditions, that would give you 1 mark in your PSPM. So I've already highlighted the word heat release. So for the standard enthalpy of combustion, the delta H is negative. Because heat is released, so the temperature drops, so delta H would be negative. Then I want you to make a big stars on these two definitions. These two are definitely the most favorite definition for chapter 2. Just remember that when the question asks you the definition for the standard enthalpy of any enthalpy, with be it either formation or combustion, you must take all the conditions as well. Okay, enable for you to get 1 mark. So let's have a quick example. I want you to match the following enthalpy with a suitable example operation. So for formation, so let's say that I have written A and B to form C. The most important thing for you to write the standard enthalpy of formation, which is called as thermochemical equation, the heat change when 1 mole of a compound is formed. Okay. 1 mole of a compound is formed. So you're gonna make sure that C has 1 mole of product. So everything that you need to balance or you need to change the mole, it should happen only in the reactant. For example, let's say that we have the balance equation to form the water. So I'm going to write the thermochemical equation for the standard enthalpy of formation of water. So the heat change when 1 mole of a compound, which is the water, is formed from its constituent element. So what does it mean by constituent elements? Is the element that you can form in the product, you must retain it as one element. So for example, we have hydrogen. So you must write it as H2 because hydrogen exists as diatomic molecule. And together we have oxygen in the product, so you must write it as O2. Okay, now O, remember that oxygen is also diatomic molecule. So what's going to happen in here is that we have to make sure that this water is in 1 mole. So what's going to happen for the H2? Okay, the mole is just the same, which is 1 mole. Okay, but what about the oxygen? Okay, it's 1 in here, right? So, but we've got 2 in the reactant. So you must times it with half. So this is the standard enthalpy of formation of water. The product form is 1 mole from its constituent element, which are hydrogen, H2 and oxygen, O2. Next, take a look at the example for the combustion of Ch4 plus the oxygen. So the combustion of hydrocarbon would release carbon dioxide and water. So what we must keep as 1 mole. We're gonna read the definition again. Heat released when 1 mole of substance is completely burned. So we know that the oxygen must be one of the reactant. So that 1 mole of substance is completely burned would refer to another reactant, which is RCH4. So we must keep CH4 as 1 mole. So you need to balance the rest of the reactant and product to make sure that CH4 always have 1 mole. Okay, so let's try. So we've got carbon. Remember that we need to balance hydrocarbon in the form of CH. That would be the easiest way. So carbon is already in 1 mole, and hydrogen at CH4 we have 4. So in H2O we've got 2, so we need to times H2O by 2. So for the oxygen we've got 2 plus 2, we got 4 oxygen in the product. We got 2 in the reactant, so we must times it with 2. So this is the thermochemical equation for the standard enthalpy of combustion. So I've already explained 2 examples, so we're gonna match them. So standard enthalpy, 1 mole of a compound, which means that for standard enthalpy of formation, you are allowed to have only 1 product. So this is definitely the example for standard enthalpy of formation. But what about this one? Well, we do have 1 mole of glucose in here, But the problem is we've got another product which is 6 oxygen. Okay, so remember that standard enthalpy of formation only form 1 mole of a product. Okay, only one product, and that product should be 1 mole. So this is definitely wrong. Next, for the standard enthalpy of combustion, 1 mole of substance is burned. Okay, let's take a look for the first example. So yeah, this is right. This is the standard enthalpy of combustion because we burned 1 mole of hydrogen. Okay, what about this third example? There is no oxygen, right? So this is not a combustion process as well, and neither a formation. So we must exclude this example. So the one that we've highlighted in green color, the one that follow the definition, would be known as thermochemical equation. For the equation that does not follow any definition of enthalpy, this is rather known as a normal balance. So this is the new type of equation that you need to remember and write for your chapter 2. There's a lot more enthalpies for you to remember and write thermochemical equation for it. First, we're gonna go for the enthalpy of formation and as well as the standard enthalpy of formation. We've already gone through this in the first video, but I didn't tell you the symbol yet. For the enthalpy of formation, the symbol would be delta HF. You must write the F as a lower subscript. You don't write it as delta HF. And you don't write it in the capital letter F as well. This is wrong. But for the standard enthalpy of formation, highlight the word standard. So you need to add one thing, which is delta HF theta. So we're gonna take the current example for the enthalpy of formation. So I've already told you that for formation, it includes heat change. So the delta H would be either positive or negative. We're gonna take a look and take the current example for each enthalpies. Okay, we've gone through this before. So 1 mole of compound is formed. So yeah, this produces 1 mole of water, so it is correct. But the second question, it produced 2 mole of NH3, so this is definitely wrong. Okay, let's take a look at the third example. It produced 1 mole of I2. So yeah, this is correct. But class, beware that all chemistry equations need to be balanced. So this is not balanced yet. We've got 1 mole of iodine gas for the product, but we've got 1 and 1 plus 2, 3 mole. Okay, so this equation is not balanced. So this well is a wrong thermochemical equation. This is not a balanced equation. For the enthalpy of combustion, the symbol would be delta HC. But if you want to write it for standard enthalpy of combustion, then you have to write the symbol theta. So the definition stated that it is a heat release. So heat release, the delta H should be negative, always negative. So let's pick the correct example. Okay, so 1 mole of compound burned. Okay, and class, I forgot to remind you that you must write the word excess. Okay, so that your reaction can be completed. So we don't care about the mole of the oxygen. Okay, so we're gonna focus for the reactant. Okay. So in here we've got half mole. So this is not right. But for here we got 1 mole of CH3OH. So yes, this fits the definition for the standard enthalpy of combustion. Third is the enthalpy of atomization. Delta H. It is the heat release when 1 mole of gaseous atom is formed from its element. So we're going to highlight the important words, which are heat release. So the delta H would be negative always. And what we need to keep 1 mole. 1 mole of gaseous atom is formed. Okay. highlight the word gases. So which is the correct example? Okay, the product would be in gas phase and it should be 1 mole. Okay, so this is the right one. And for the beryllium, it is really wrong because the product is in aqueous. Okay, the product should be gaseous atom for the enthalpy of atomization. Enthalpy of neutralization, which has a symbol of delta H, and it is the heat release when 1 mole of water is formed from the neutralization between acid and base. So you guys definitely know that the neutralization always happens between acid and base. So the equation is still the same, but you need to note that you have to keep the water as 1 mole in the product. So highlight the mole for the water. Okay, which has the 1 mole of water? Yeah, the top one. So this is definitely wrong, even though they are all the neutralization process. Okay, but this one fits the definition for the enthalpy of neutralization as it produces 1 mole of water between acid and base. So again, heat release, the delta H would be negative. Enthalpy of hydration, which has a symbol of delta H, HYD. Yeah, you need to write the hydration as HYD, not delta no, not delta HY. Yep, it should be written as HYD for hydration. It is the heat release when 1 mole of gaseous ion is hydrated in water. Okay, so heat release, the delta H should be always negative. Let's highlight the important word. 1 mole of gaseous ion is hydrated in water. Okay, for all the equation, you don't have to write it as plus H2O, plus H2O. No, because we've already know that hydration means you hydrate it with water. So what about the mole of the gaseous ion? The reactant should be in gaseous ion form. So which one has the gaseous ion? Gaseous ion, alright? So the correct example would be the bottom one, because 1 mole of gaseous ion is hydrated in water. So the product should has the same formula Na+, but the phase would be changed into aqueous. So whenever I saw that you have the end product of aqueous in the form of gaseous ion, then you must have written the thermochemical equation for enthalpy of hydration. Lastly, but not the very least, is the enthalpy of solution, or you can call it as dissolution as well. So the symbol will be delta HSOLN. It is the heat change when 1 mole of substance is dissolved in water. So highlight this word, heat change. So the delta H can be either positive or negative when 1 mole of substance is dissolved. So 1 mole of a substance, we do not refer to any ion or anything. So this would be your reactant. So the reactant would be 1 mole. Okay, again, it dissolved in water, so all your products should be in aqueous form, in gaseous aqueous form. So what is the 1 mole that is being dissolved? That would be the KCl. The second example is wrong because we did it with 2 mole of Na2SO4. So we only require 1 mole of a substance dissolved into water to form gaseous ion. How do you going to identify or differ between the enthalpy of hydration and the enthalpy of solution? Okay, remember that for the enthalpy of hydration, the reactant is in the form of gaseous ion. But for the enthalpy of solution, the reactant is in substance. It can be in solid or aqueous. But the end product is just the same. They are both form gaseous ion. Okay, the only difference is the state of the reactants. In order not to confuse you, so you must remember this already, the heat change, so delta H would be positive or negative, heat release, the delta H would be negative, and then heat absorbed, that would be delta H positive. Okay, we don't come across a for the definition that involve delta H positive. Okay, that's why I told you there's more definition as we go along this chapter 2.